We've got two more topics for this lesson. The first one is on arc length, or how to find part of the circumference of the circle. And the second one is converting between decimal degrees and degrees, minutes, and seconds. So looking at the formula for arc length, we have S. For some reason, S represents the arc length. I'm not real sure why, but S is the arc length of the circle. R is the radius, and theta is the central angle in radians. If the central angle is in radians, it's really simple to find the arc length. You just multiply it by the radius. If the central angle is in degrees, you'll have to convert to radians before you can use your formula. Or you can think about the fraction of the circumference that you're finding and set it up that way. So we'll take a look at both types. So we've got a little picture here to demonstrate, again, our central angle measured in radians. We can use our simpler formula. The radius, of course, is from the center to an edge of the circle, and then the arc length is that intercepted arc that's created by that central angle. Our last formula is to convert between decimal degrees, so like 57.3 degrees, and what are called degrees, minutes, and seconds. So it's a more precise way of measuring angles when you talk about the minutes and seconds. And just like minutes and seconds in an hour, you've got 1/60th of a degree would be 1 minute, and 1/3600th of a degree would be 1 second. So starting off with arc length, first we're going to do the simple formula. We're given the measure of the central angle in radians. We know the radius, so we get to just multiply those two values together to get the arc length. So we have measure of the central angle, pi/2, times the radius. I would like you, if it's possible, to give the arc length in an exact form. So we've got 5 pi/2, as well as a decimal form, which in this case is 7.854 inches. So again, as a reminder, what we just found is if you were traveling along this circle between the arc, the intercepted arc, you would travel about 7.8 inches. The next one is in degrees, so we can't use the shortcut of the formula. So what you could think about is if we found the whole circumference of the circle, that would be 2 pi times the radius. But we only want the fraction of the circumference that's covered by a 120-degree angle. So here's one way to set it up, and then you could simplify that one. I want to show you the other way before we get our answer, is to convert the degree measure to radians. So remember, the formula for converting from degrees to radians would be to multiply, and again, I want my degrees to cancel, so I put that in my denominator. I want radians to be the unit for my answer, so the pi goes in the numerator. And then, so that's our central angle in radians, and then multiplied by the radius. Either way, when you simplify this, so we've got the 120 over 180 gives us 2 pi over 3 times 7.5. And when we multiply the 2 by 7.5, we get 15 pi over 3, or an exact answer of 5 pi centimeters. An approximate answer for this one would be about 15.708 centimeters. Our next topic, for example, we are given the arc length and we need to find the measure of the central angle in radians. So we get to use this shortcut formula, theta times the radius, substitute the arc length, substitute the radius, and solve for theta. Dividing both sides by 8, we get 3/4 radians equals theta. You can choose to put radians as the label for your angle measure, or without any label at all, that is assumed to be in radians. So you can leave your radian angle measures without a label. Next, again, we've got arc length equals theta times radius. So we substitute 31.7 for our arc length, solving for theta, and our radius is 8. So when we divide both sides by 8, we get an angle of approximately 3.963 radians. And our last example is converting between decimal degrees and degrees, minutes, and seconds. So remember, we use that conversion that 1/60th of a degree is 1 minute, and 1/3600th of a degree is 1 second. So when you convert from decimal degrees to degrees, minutes, seconds, you only need to worry about the decimal part of the degree. And the first thing you do is you multiply it by 60, because the 1/60th of a degree is 1 minute. So 6/10ths of a degree multiplied by 60 will give you how many minutes are in that degree. And in this case, this works out evenly. We get exactly 36. So this converts to 135 degrees, 36 minutes. So this little, the 1/ is the unit for minutes, and the 2, or the apostrophe, is for seconds. Since that one converted exactly, we have no seconds on this one. Our next one, again, we start by taking 0.23 and multiplying by 60 to convert to minutes. And in this case, we got 13.8 minutes. Well, there's still a decimal part, so we take that next decimal part and see how many seconds that would be. So we multiply that by 3,600, and 0.8 times 3,600 is 2,880. So when we convert this degree, we get 51 degrees, 13 minutes, that was the whole number when we multiplied by 60, and then 2,880 seconds. The last example is converting from minutes and seconds to decimal degrees. So we do the opposite. We divide by 60 and divide by 3,600. So we take our 85 plus the 18 minutes divided by 60 minutes in a degree, plus the 30 seconds divided by 3,600 seconds in a degree. So this gives us 85.308 degrees, converting that to decimal degrees. And your 2 U-Try questions.